Channel Balvigyan Bharti with Avilas Sarkar, and we are progressing on time and work problem solving session. There we have reached till 22. As I said, I will move on to 23 in this episode. So 23 problem said a man can do a work in 20 days, can do a work in 20 days and a woman in 15 days. If they work on it together for 5 days, then the fraction of work that is left is how much. The question has ended here and they are giving some options, but I am not taking options. Means you can say that I am not taking that according to the options. I will go ahead. Rather, I will solve it as the question said, and I would want to reach to the final answer without seeing the options. So options will sometimes people try to manipulate according to the options and they forget to do the sum which is needed to be done. Okay, so that concept is missing somewhere. If options is there, is always a very dependable situation. So I don't want to put my observer or the audience into something means in dependency. Rather, I will solve my own way and I want to reach to the final answer automatically without seeing the options. That is my intention. So that will build some confidence or more confidence than we are having options. Okay. A man can do a work in 20 days and a woman can do 15 days. So rate of work for man is equal to 1 by 20 and rate of work of woman is 1 by 15. If they work on it together for 5 days, so in that case when they work together, so I have to find when men and women are working together their rate of work. So their rate of work will be how much? 20 and 15. What will be the LCM for them? Both together 60 will be the LCM. So 20, this is 3, this is 4, definitely 7 by, this is rate of work. So the first 5 days, if they work together, women plus men, they work how much fraction? 7 by 12 fraction. So then what is the work left? Work we know is 1 always, minus 7 by 12, so that means 5 by 12. So this is your answer. Okay. So I move on to the problem number 24. 24. So 24 will start from here. So let me check which one is correct, because I want to get some variety, not that every time I'm discussing the same kind of problem and you may be bored seeing that. so I don't want to make you bored, rather to make you learn something different. Okay, so that's why. Okay, let me check this. 12 men can complete a work in 8 days. Complete a work in 8 days. Okay. 16 women can complete the same work, can complete the same work in 12 days. 8 men and 8 women, 8 men and 8 women started working and worked for 6 days. How many more men are to be added to complete the remaining work in 1 day. So let me understand this problem. This till now whatever you have solved, it is bit a different test that you can understand. 12 men can complete a work in 8 days. So rate of work of men from this information is 12 men can complete in 8 days. So that means what is the rate of work? 12 men into 8, this is the complete engagement of 12 men. So this is 8 into 12 is 96. Rate of work of women, that is 1 upon, that is complete work is 1. We always take if it is not specifically said something. That one case we have found, there is number of toys being made by people. So that is the only case where this is specifically quantified. Otherwise, if it is a single job or a job, a piece of work, all these cases will take is 1. Again and again I'm saying, you take 1. So if we are taking 1. Okay. 16 women can complete the same work in 12 days. So 16 into 12. So rather, it will be easy later if we don't calculate it right now. Okay, I will keep it like that. Now, this is the condition. Now, what is happening? The actual work being started with 8 men and 8 women started working and worked for 6 days. So, my first part of information, if I work with this, so my 8 men plus 8 women working for 6 days. So that 8 men, their rate of working is, that we are calculating work per day per men, because I am considering men also, per day per man. So this is the rate. So for 8 men will work. Now if I multiply this with 8, I will get 1 day 8 men will do how much? So this is 1 by 12 into 8. That is the men's part, and women's part 8 into the same way. The rate of work will show you how much 8 women can do in a day. So for 6 days, how much they do? This is work done per day per man. into the men. So work done per day by 8 men, work done per day by 8 women. So this is the total work done by 8 men and 8 women in a day into the days work done by 8 men and 8 women in 6 days. Understood? So now it will be easy to calculate. So how much it is? 1 by 12 plus 1 by 24 into 6. So this will show you how much fraction of the total job done by 8 men and 8 women in 6 days. That my intention to calculate first. So this is 3 upon 24. Okay, 3 upon 21 by 8 into 6. So that is equal to 3 by 4. That fraction. So remaining is how much? Remaining job. Remaining job is 1 minus 3 4, that is 1 by 4. Okay, I rub this part. This is done. Okay, now in the second part what it said, how many more men are to be added to complete the remaining job in one day. So next, your target is fixed for a day. Either you do this manpower or this men and women, but your target is to complete in one day. So for one day, at least this men and women will work, and along with that, if anything remains, that has to be done with the additional men. So for my first intention to find another day, how much the 8 men and women are doing. So they are doing further fraction of work that can be calculated from this in a day into 1. This is another day. How much fraction is already they have done something 3 by 4, so remaining is 1 by 4. Out of that, how much they can still do. So this is 1 by 12 plus 1 by 24. That gives how much? 1 by 8. We have calculated already. So 3 by 24 is 1 by 8 fraction still do. So further remain even this 8 men and 8 women can do a day's work. So further how much remains? 1 by 4. So that is equal to 1 by 8. So this has to be completed with additional men. So men's rate of work is this much. So the additional men required is equal to fraction of job divided by rate of work 1 upon 12 into 8, isn't it? 12 into 8. So all total 12 into 8 will go up, 8 will go down. So that is equal to 12 men. So additional men is required. Your answer has to be 12 men additionally required. This will be your answer. Understood? This can be done in other way also. How we will do? This part is over. Remaining job is 1 by 4. So what I will do next to this, instead of doing this, we can put it in equation. Let's say we are assuming, so m men has to be added more. So my strength is now 8 plus m. So 8 plus m with their rate of work 1 by 12 into 8, with this they will do for one day, and on the remaining women's are not added. So women's will be 8 with their rate of work 16 into how much? 12. They will do for one day. So I am assuming this is for each day, and this part must be equal to 1 by 4 because the remaining is 1 by 4. So this can be put it in one equation where only unknown is m. So that can be calculated from this. So basically this will become 8 plus m by 12 into 8, and now 12 is common, 12 we can go put it on that side, plus 8 upon 16 and 12. If we go that side, this will be 3, this will be 2. So now this is half, so half will go that side, so ultimately this will become 3 minus half, that means equal to 6. 5 by 2, 5 by 2, 2 will cancel it out, so from there it is 8 plus m is equal to 20, so m is equal to 12. Okay, so this way the second part of the sum that I progressed in 2 steps, instead you can put it in 1 step and can calculate the number of men added, because if number of men added is m, so the number of men will be enhanced to 8 plus m. So they will contribute for 1 day with their rate, and women automatically they are already there in the same quantity, so same number, so that they will work in the same way they are doing earlier. So all total the fraction of job has to be the remaining job, so then you will get the answer. Okay, we will move to the number 25. So number 25. Okay, an air cooler and air conditioner okay, and you can cool a hall, can cool a hall in 40 minutes. Okay, while another takes 45 minutes. Okay, to cool under similar condition, conditions. If both air conditions are switched on, if both ACs are switched on at same instance, then how long will it take to cool? Will it take to cool the room approximately? Okay, so this is in a different way of representing the problem. Till now what we did, we have worked with a live resources, that means men, women, something like that, boys and all that. Now these are the things that is we are looking with the product or a machine, how they does the work, but at the same time that you have to understand whether it is machine or a resource who are live, their function is to perform a job. So means this air conditioner is also performing a job. What it does, it is cooling a hall. That is the job, and that job is a complete job. So now the first AC, an AC condition, so you can name it first or second. The rate of work of first, you can say the first one is in 40 minutes. You can, so the units are in minutes, so I need not to bother to convert it in any other units because both the units are the same. So rate of work for the second AC, so you can give it a name of first and second. The second AC is 1 by 45. So this is the only difference. You have to correlate with in case of the live resources. So under similar conditions, so there is no deviation in the condition. All the windows and the doors are closed. There are same number of persons, same of commodities occupied in the room. There is no changes in the room, and the outside temperature of the atmosphere is also same. So all conditions, on that condition, the first AC is working, second also working the same condition, and in that case it can cool. That means they can bring down the temperature of the hall to some extent on the same temperature. Okay. If both ACs are switched on at same time, so both ACs put into the hall to do the job simultaneously, and they being switched off together. Okay. Although that they being installed in the same hall, alternatively they are being used, but at this time to see how they are performing together, that being switched on the same instant of time as long as they take cool. So how long it will. So after that, materialistically there is no difference when with the way we are working with the resources, that is light. Then after there is no difference. So what is our motto of calculating the rate of work? When first and second both ACs are working. So this is your equation. What is, it will be the multiplication factor of this two, 40 and 45, that is 8 and 5, 72 into 5. So that means 5 into 360. So 360 will be the LCM. So 4, here it is 90. So this is equal to 9, and 45 here I will get 8. Suppose 8, 40, this is 8. So this is 17 upon 360. So this is rate of work when both are doing. So the time taking together is equal to 360 upon 17 minutes. Okay. So now I can calculate it in decimal and all that, or you can keep it like that also. You can put it in hour, and so that is up to you. If you want to put it in hours also, that you can do. But that depends on the options being given. Then after the following result you can bring with your own knowledge of converting this minutes into hours and all that. Okay. So I will move not in this video. I'll move on to the number 26 in the next video. As of now, I am ending this, and just keep watching my channel and try to subscribe. More and more people should get the advantage of joining with me, and just this is your responsibility. Whoever is already being means subscribed or attached to my channel, their responsibility to spread it like that more students can get the advantage of my effort. So thank you for watching, and give me the enthu, or the, you can say, the interest of keeping my good work by watching more and more numbers. Thank you.